This video is going to cover section 5.6, the fundamental theorem of calculus. So if you have g of x equals the integral of f of x dx, then the definite integral of f of x dx from the interval a to b is simply g of b minus g of a. And so g is the antiderivative, so that's what this little integral symbol is telling you to find. And so you're just going to find the antiderivative, and then you're going to plug in the endpoints to find an actual value. And so this is solving for a definite integral. Before, we didn't have our interval from a to b, and we were just solving for a generic antiderivative, and we had the plus c at the end. Now we're going to be substituting values in, and you are going to get an exact value. So we are using integrals to find the area under the curve, and this is going to be used to find the exact value instead of using Riemann sums. There is a second part to the fundamental theorem of calculus, but we are going to do that in chapter 6. So the first example, using the fundamental theorem of calculus to evaluate the following. So you'll recognize this integral. It's the integral of 2x dx, but now we have these numbers at the top and the bottom of our integrand, and that's telling us to evaluate the area under the curve 2x from 1 to 3. And so we're going to calculate this numerical value, but we're going to do this algebraically. So we're not going to use a Riemann sum or a trapezoid. We're not going to graph it and count the squares. We're going to find the antiderivative and then plug the values 3 and 1 into that antiderivative. So the antiderivative of 2x is just x squared, and then don't forget your plus c. But one thing that's different with your answer is that you're going to have this bracket at the end, and then you're going to have that 1 to 3, and that's telling us to evaluate this antiderivative from 1 to 3. So we're going to plug in 3, and we're going to plug in 1, and we're going to subtract it. So it's always g of b, 3 is your b, minus g of a, and 1 is your a in this case. So we would get 3 squared plus c minus, and then the value that you get when you plug in the a, so 1 squared plus c. So if we were to distribute that 1 squared, the positive c and the negative c are going to cancel out, so you no longer have the constants. You're just left with 3 squared minus 1 squared, and you get a value of 8. So I'm just illustrating this one part with the plus c. They do and they will always cancel out. You will never have a plus c in your answer for a definite integral. But I just wanted to show you that it should be there when you're showing your work, at least within the first two steps, or sorry, in this first step. You don't have to show it from now on. You can just plug in the values and get a numerical value. Let's try a second example. Evaluate the integral of 10 sine of x dx from 0 to pi using the fundamental theorem of calculus. So the antiderivative, remember 10 is just a constant, so I can worry about that at the end. The antiderivative of sine is a negative cosine because a negative sign is the derivative of cosine. So since this derivative is positive, that must mean the antiderivative is a negative cosine. And then the 10 is just a constant. So my antiderivative is negative 10 cosine of x plus c, evaluated from 0 to pi. So now I'm going to plug in pi, and I'm going to plug in 0. You'll notice I didn't write the c's anymore. After the first antiderivative, you don't need to anymore since they will always cancel out. And you should always get a numerical value when you're doing a definite integral. So negative 10 times cosine of pi minus negative 10 times cosine of 0. Knowing your unit circle, you'll know that the cosine of pi is a negative 1. The cosine of 0 is a positive 1. So I get negative 10 times negative 1 is a positive 10. And then subtracting a negative 10 is just like adding, and so you get a value of 20. And the last value, or the last example I have, is the integral of 12 times 4x plus 3 squared dx, evaluated from negative 1 to 3. And so remember, with these power rules, you also want to think about chain rule. And since the derivative of the inside is 4x plus 3, and I must have multiplied the 4 out to go to the antiderivative, I have to divide the 4 out. And the previous power was 3, so I also have to do this 12 divided by 3. And so essentially we're doing 12 divided by 4 times 3, which is just 12 divided by 12, which is 1. And then the previous power was cubed. So my antiderivative is 4x plus 3 cubed plus c, evaluated from negative 1 to 3. When I plug that 3 in, and I plug in the negative 1, I'm going to get 12 plus 3 is 15, and then cube it, and then subtract 4 times the negative 1 plus 3, which is negative 1, and then cube that, and you should get 3,376. When I get back tomorrow, I will show you how you can use your calculator to double check your work. For right now, you guys are going to get just a worksheet to practice antiderivatives and evaluating these definite integrals. So work on this. I put the answer key on the hub. I apologize that the numbers got cut off on the far left, so they go in numerical order. Check your answers with my answer key under today's date on the hub, and just hold on to the worksheet until tomorrow. I hope you have a good day, and I will see you then. Bye.